So let us understand this here. So let's take example this here. How many endogenous variables here we have? We have the 3 endogenous variables. So that means number of G is 3. That is, the number of G will be 3 here. Now what will be G minus 1? That is 2. Now let us say to examine the order condition of the first equation, that is for the demand equation here. In the demand equation, G minus 1 is 2. What is the M? That is how many numbers are missing which is not present into the quantity demand equation. We can observe quantity demand is there, price is there, income is there. Only thing which is missing, that is the quantity supplied. So that means the M is equal to 1. Now if we compare here what we are observing, since M is less than G minus 1, therefore demand equation is not identified. Similarly, we can do for the supply function. So supply function, again what we have, G minus 1 is equal to 2. What is M? That is how many variables are missing from this equation. So here we have only price, that means the 2 equation. One, the quantity demanded, another, that is income is missing from this. So the number of M is equal to 2. So basically here what I have, quantity demanded and income. And here we have only one, that is the quantity supplied is missing. That means here this M is equal to G minus 1. So therefore the demand equation is exactly identified. So that is the first condition, that is the order condition. Now let us talk about the rank condition. So here the rank condition, basically here we construct a particular table. So how we construct the table? A column for each variable, a row for each equation. So the table skeleton is a column for each variable. If you have the 4 variables, there should be 4 columns. If there is the 3 variable, there should be 3 columns. If you have 4 equations, then there will be 3 rows. If 4, then there will be 4 rows. So let us consider now what will be the case here. For each equation, put 1 in the column if the variable that corresponds to this column is included into the equation, otherwise put 0. And then for the particular equation, delete the rows of the equation that is under consideration. Write out the remaining elements of each column for which there is a 0 in the equation under consideration. Consider the resulting array if there are at least G minus 1 rows and columns that are not all 0, then equation is identified, otherwise not. So let us take an example, then it will be very clear to us what we mean by these conditions here. So let us take this example. So first we will construct the table. So how many variables we have here? We have quantity demanded, price, income, and the quantity supplied. So that means 4 variables we have in the system. So it means there should be 4 columns. How many equations we have? We have the 3 equations. That means there should be 3 rows. So first thing, construct the table here. So we have 4 columns and 3 rows, the demand equation, supply equation, and equilibrium condition. Now, so for each equation, put 1 in the column if the variable that correspondent to this column is included into the equation, otherwise put 0. Now let us take the demand equation. In the demand equation, this column is quantity demanded, that is very much present here, so we will put 1 here. Now in the demand equation, we do not have the quantity supplied, then we will put the 0. However, in this equation again we have the price, so we will put 1. Again income is present, so we put 1. So that's the basically we are following this step here. Now for the second equation, quantity supplied, so what we have, the quantity demand is not present, so we'll put the 0 here. Now the price is present, so we'll put 1 here. Sorry, quantity supplied is present, so we'll put here, and the price is present, so put here. Income is not present in this equation, we will put 0. Now for the equilibrium situation, what we have only quantity demanded here and the quantity supplied, it is here. Neither the price nor the income is present in this equation, so we put 0 here. So we have completed the task, we have to construct the table up to here. Now let us move to the second part. Delete the row of the equation that is under consideration. So let us first consider as the supply equation. So we are testing the rank condition of the supply equation. So the first thing what we have to do, we have to delete the row of the equation that is under consideration. So we are deleting this particular row here. The first task, delete that row which is under consideration. So next, what is saying, write out the remaining elements of each column. So each column remaining elements for which there is a 0 in the equation under the consideration. So where we have 0, we have 0 in this equation and in this column and in this column. That means now we are concerned only with the column of this and this, because in these two cases we do not have 0, so we will not put the consideration here. So that means now what we have, write out this part, that is 1 1 1 and 0. So here we have new table in this form. Now the next part is what it says. Consider the resulting array if there is at least g minus 1 rows and columns that are not all 0. So g, that is the number of indigenous variable, that was 3. G minus 1, that is 3 minus 1 equal to 2. Now we have to consider rows and columns that are not all 0. Now let us take this particular row. So not all elements 0. In fact, there is no 0. In this only one column we have 0, but another is no. If you take the column again there is no 0 at all. Here at least one row is not 0. That means this g minus 1 should be equal to this here g 2, and therefore the supply function is unidentified, because here we have the 2 rows and 2 columns which does not have all element to 0. Therefore this particular supply function is identified we have. Now what is the under identification we have? So let us consider here the simultaneous equation model. This again what we have the rank condition of this. So what is the order condition we have? So what are the order condition we have here? So the number of endogenous variables, how many we have? We have 1, 2, 3. So we have 3 endogenous variables. So that means g here is equal to 3. So we have 3 endogenous variables, that is the g is equal to 3 here. Now what is the g minus 1? So g minus 1 is equal to 2. Now let us take the quantity demanded equation here. So in the quantity demanded equation, what is the value of m? That is the number of missing here. That is only the quantity supplied is missing. So that means m is equal to here 1. Now since m is less than g minus 1, that means it is under unidentified. Now if you look the supply equation, in the supply equation, so this is for the demand equation. Now if you look the supply equation, again what we have, the g minus 1 is equal to 2, because the number of endogenous variables are 3. Now what is the m? So here in the quantity supplied, only the variable we are missing is the quantity demanded. So again the m is equal to 1. So again what we have, m is less than g minus 1. So that means again under identified. Now let us take the rank condition here. So let us take the demand equation here. So that we are taking the demand equation, that means the first thing what we have to do, we have to delete this row. So for the demand equation, the first task we have deleted that row. Once we delete that, now what we have to consider? We have to consider only that column where we have 0. So here we have only one column where we have 0. So the second, so this is the part 2, what we have, only we have one column, that is the Q, S1 and 1, that is the supply equation and equilibrium condition here. Now, what we know, that G minus 1 is equal to 2. Then the number of rows and column here, what we have, only 1. So that means here again this number of rows and columns is less than g minus 1. That means there is under identity. This equation is under identified. Now if you take the supply equation here, this, so if you are taking the supply equation, then what we have to do, we have to first delete this equation. Now consider only that column where we have 0. So we have again the 0 only, the delete the row. But again here what we have only 0 only first column. So the second part will be Q demanded, which we have 1 1. Here what we have demand equation, and here we have equilibrium condition. So again here in this case, this number of rows and columns are less than G minus 1. So again what we have under identified situation here. And same will be the equation with the equilibrium. So this is the whole scenario where we are observing that we have what? We have under identification of the system of equation. Now let us take the another situation. So here we will take the another situation. So now let us see how many G we have, the number of endogenous variables. So we have the number of endogenous variables. So how many we have? Again we have 3. So G minus 1 is again 2. Now let us take the order condition of the demand equation here. The demand equation here. So in that case, how many variables are missing here from there? So from that, one, we have the quantity supplied is missing. So that is again M is equal to, we have 1. So again here M is equal to less than G minus 1. So that G minus 1, that means what we have again under identification we have. Now let us take the supply equation. So this is the demand equation we have. Now if you take the supply equation, what we can observe in the supply equation, again G minus 1 is equal to 2. Now what is the M? Number of variables missing from this particular equation, whether it's endogenous, whether it's exogenous, whether it's the lag endogenous. So this exogenous variable is missing from here, and this quantity demanded, which is endogenous, this is missing here. So here M is equal to 2. So in that case what we have, M is equal to G minus 1. So that means it is exactly identified. Now let us look at the rank condition here. So in the rank condition what we have the 4 columns. Now let us we are taking the supply equation. So the first thing what we have to do, first task for the rank condition, we have to delete this. Then consider those columns in which we have 0 element into that particular equation. So we have this quantity demanded and this is income. So here we have again demand equation 1, and here again we have 1, and the equilibrium equation for we have 1 and 0. Now what we have is we have G minus 1 is equal to 2, and here the number of rows and columns what we have, that is also 2. So that it means G minus 1 is equal to 2, which is equivalent to this number of columns and rows of the second matrix, which does not have all the elements equal to 0. Therefore, this is the situation of exact identification. Now let us consider the third situation here. So in this condition what we have the again G, that is the number of endogenous variables we have 3, and let us take the supply equation here. So what we have M here, that is the number of missing observation, missing variables. What we have the quantity demanded and the income. So basically we have 2. So G minus 1 is equal to 2, which is equal to M. So that means that is identified here. Now let us take the rank condition of this supply equation what we have. So first task, we will delete this supply equation and will take all those which basically we have 0 here. So that means we have this quantity demanded and what we have Y. So thus here we have the demand equation, here we have the equilibrium equation. So 1, here 1, 1 and 0, and we have seen that this is the case of exact identification. identification. Now let us take the demand equation here. So if you are taking the demand equation here, so in that case, so this was the supply equation. So let us take the demand equation here. So in that case, what we have in this. So again, G is equal to 3 and G minus 1 is equal to 2. And in this case, how many we have? The missing, that is the value of M. That the missing what we have, this the lag endogenous, and we have missing the quantity supplied. So here M is equal to 2, so which is equal to G minus 1. So again, it is the exactly identified. Now let us look at the rank condition here. So now we are looking at the demand condition. So first what we will do, we delete the that particular row here. So we are deleting the demand equation here. So if you are deleting the demand equation, what we have? So we have to consider only those where we have zeros here. So here we have the demand equation is deleted, and we have the supply equation. So here we have quantity supplied, that is 1, and here we have P minus I minus 1, that is 1, and the equilibrium condition here we have 1 and here we have 0. Again, it is the unidentified we have. So this situation will be basically the exact identification in both cases here. Now what is the over identification we have? Now let us take that equation here, the quantity demanded, where the income as well as the wealth has effect on this quantity demanded. Now let us take the order condition we have. So again, the endogenous variable we have 3. Now let us take this the supply equation here. So in the supply equation, what we have, missing observation, what we have, the quantity demanded, income as well as this wealth. So here G minus 1 is 2, M is equal to 3. So in this case of the supply equation, what we can observe, this M is more than G minus 1. So that means it will be over identification situation. Now let us take the rank condition here for the supply equation. So what we do, first we delete this here. Once we delete it, we have to consider only those columns where we have 0 element in this equation. So what we have, the demand equation and the equilibrium equation here, and the first we will take the quantity demanded column, which will be 1 and 1. Then we will take the income column, so it will be again 1 and 0, and we will take the wealth column, again it will be 1 and 0. Now how many rows and columns of this array which does not have all the elements equal to 0? So here 1, where all the elements is non-zero. Here this column, at least one of the elements is non-zero, and here again there is at least one element which is non-zero. So that means it is 3. Now what we have, G minus 1, that is 3 minus 1 is equal to 2. So again this situation also shows the our case of our identification. So we have seen that both the order condition and the rank condition, how we determine this following a systematic approach. And we have the 3 possibilities of exact identification, under identification and over identification. Now depending on that situation, we will see, we can decide whether which method we should use to estimate the parameters. So estimation of the simultaneous equation of exactly identified, we can use the ILS method. So basically, to be used only when equation in simultaneous equation model are found to be exactly identified. So step 1, find the reduced form equation, estimate the reduced form parameter. ILS basically stands for indirect least square. Why we call indirect least square? Because using the least square, we are estimating the reduced form equation, and through that we are able to find out the structural parameters. That's why we call indirect least square method, and that is only possible when we have exactly identified equation. Then step 3, obtain the unique estimates of the structural parameters from the estimates of the parameters of the reduced form equation. Step 2. For example, let us take an example here. So what we have these 2 equations here. We cannot estimate this because of the simultaneity problem. So what we can do, we can get the reduced form equation here. and we estimate this using the OLS. Let us say what we have this scenario here. So we have estimated this, the pi 3 and the pi 4 parameter. Now beta 0 at pi 3 upon 1 pi 4, which solves out to this. So this is the situation what we have used ILS method in this case here. Now estimation of the over identification equation. So three stage least square method we can use if we have over identification. So method is to replace the stochastic endogenous regressors, which is the correlated with the error term, and causes bias with one that is non-stochastic and consequently independent of error term. How we do that? So this involves the following two stages. So why we call the two stage least square? Stage 1, regress each endogenous variable on all the predetermined variables in the entire system by using the simple OLS and obtain the fitted value of the endogenous variable of this regression. So here we are regressing endogenous variable only on the exogenous variable without consideration whether it is depending on the endogenous variables also. Then in the stage 2, use the fitted value from stage 1 as the proxy or instrument for the endogenous regressors in the original structure from the equation. So basically what we are doing, let us say consider this model. So this quantity demanded is endogenous variable. It depends on the price, which is the endogenous variable. Now in the two-stage least square method, what we do, we are not using this structure. Rather than we will regress this on all the exogenous variables. So regress each endogenous variable Qi and the Pi on all the predetermined variable, that is income, wealth, lagged endogenous, and let us say minimum support price in the entire system by using the simple OLS and obtain the fit and values of endogenous variables of this regressor, that is this, and so that is we are using we are getting the estimated value of Qi and the Pi. So this. Now, use the fitted value from stage 1 as the proxy for the endogenous regressors in the original structure of equation. So instead of using the original Py, we will be using the P estimated value. Here, instead of Qi, we will be using the estimated value here. So that's basically we do in case of our unidentified equation. So today we have discussed that what is the simultaneous equation, why we will not be able to use the OLS method, and how we can estimate the simultaneous equation models. Thank you so much.